Now we are going to solve one example problem to see how much axial force and bending moment develop in a beam if we have non-uniform temperature variation. Okay, so here we have one beam, and then beam is subjected to temperature variation from 40 degrees Celsius to 30 degrees Celsius. 40 degrees Celsius is at the bottom, and at the top we have 30 degrees Celsius. So here our mean temperature, average temperature is 35 degrees Celsius. Now room temperature is your 27 degrees Celsius. Now here we have to find axial force developing due to the non-uniform temperature variation and bending moment developing due to the non-uniform temperature variation. Okay, so axial force which is going to develop, that is your EA alpha times delta T. Here this delta T is the difference between the mean temperature, average temperature with respect to room temperature. So here delta T is the difference between the average temperature and room temperature. Okay, so now here if we put the value of A, if we put the value of E, if we put the value of thermal coefficient and delta T, you will observe that the 384 kilonewton axial force is developing for this case if we have both end are fixed condition. Okay, and moment that is going to develop, that is E I by D alpha times delta T. Because E is your 200 GPa, so now we are converting it into Pascal. So we are multiplying with 10 to the power 9, and I is already given. Coefficient of thermal expansion is your 12 into 10 to the minus 6 per degree Celsius, and here the difference between the temperature at the bottom and the top, and the depth here we are assuming as 200 mm. Okay, 200 mm is the depth. Now, if we solve it, you'll observe that 6,000 Newton meter or 6 kilonewton meter moment is developing at both the end. Okay, so here if we want to present it graphically, okay, here if you want to present graphically, you'll observe that the axial force is developing, that is your 384 kilonewton. This side also 384 kilonewton, and moment is developing here, that is your 6 kilonewton meter and also 6 kilonewton. Okay, and here temperature deviation from the room temperature, that is your 3 degrees Celsius, and here we have 13 degrees Celsius. Okay, so here we have solved one problem considering non-uniform temperature variation, and due to the non-uniform temperature variation, there will be axial force and bending moment if both ends are fixed, if both ends are constant. If one end is free, in that case, there will not be any axial force or the bending moment in that beam. Okay, because that beam is free to expand. If the beam is free to expand, then there will not be any axial force or bending moment. If we restrict it, then due to this restriction, there will be axial force as well as your bending of the beam. Okay,